Oh! Oh!
No, stop.
Is it going now?
It's loading.
Oh!
Okay, now it's good.
Hey, hey guys.
So what have we actually talked about?
I don't know how long has it been off for?
Probably 5 minutes.
The whole time?
The whole time.
Yes.
Okay. Hey guys, welcome back. We're preparing right now to launch the rocket. Some of our other members are doing great important work right now, troubleshooting, sanding,
explaining,
tomfoolery. Then there's Dave. He's always great. He's doing great
yes.
things. Dave's always doing
around.
great
Shout out
things.
to Dave.
Right now, I'm holding the motor that our rocket is going to fly on.
Is it cold in your hands now?
It's very cold in my hands. This is an Aerotech K1000 TP, I believe. It is a small motor compared to other motors that we could have used for this competition because we're flying with a 4-inch airframe, 4-inch diameter airframe. It's a lot smaller.
It's only 4 inches tall.
The rocket is 4 inches tall. It's actually 108.
I have no idea. That's you and Dave.
It's 8.5 feet, something like that.
So
Daniel
8
changes
times
things and
12.
doesn't tell me.
What is 8 times 12? Well, that's off your head.
It's like 106. Actually, it's 108 inches. I do remember. It's 108 inches or so. So this is all it takes to send our rocket 4,700 feet in the air, which will be controlled down to 4,100. Fun fact.
By air brakes.
Yes, fun fact. This rocket is propelled by ammonium perchlorate, which is the same stuff used in the rockets that NASA shoots off in the real deal. We're just using a lot less of it.
What class is this?
This is a Class K,
K?
I believe.
Okay. How many
How many Ks is
Newton
that?
seconds of impulse is that?
I don't know, but what I do know is that it launches us up real high, real fast.
How fast?
How fast, Seth?
Somewhere around 400 miles an hour.
That's a lot of speed.
That's a lot of miles per hour.
If
And
you
a
were
lot of G's.
A lot of G's, about 550 feet per second. Like 10 G's?
fun
8 or 9 G's.
fun fact, pilots that fly planes have to experience G's up to like 7, I think.
7. If you're going up to 7, you're close to death.
If you're going up 7, it's no bueno.
Oh yeah.
They can do 15 for half a second. Imagine if you were on that rocket right now.
Whew. Me with vertigo.
That would be tough.
They'll experience it from video perspective from the camera that will be on the rocket.
Oh, in live
that's
stream?
so true.
Or,
Oh no, later when I post
I was
it.
like-
being live streamed.
No.
Yeah, so we
No,
will be
later.
Yes, we will be attaching a camera to the outside of this rocket and launching it, which is very fun.
Yeah.
Very,
Let's go
very
from
fun.
the bottom to the top of the rocket.
Okay.
And describe it.
Okay. So this rocket ends with a tail cone, which is basically kind of like an end mechanism we put on the end of the rocket to retain the motor. Oh wait, no, it's opposite. Hold it like that. And so that's the end of it. It's tapered, slightly like a nose cone, but in reverse. Because it's a tail cone.
Reverse nose.
Then we have the thrust structure, which is the system that holds on to the motor put into the rocket and distributes the thrust that the rocket produces throughout the body of the rocket. It also holds onto our fins, which helps stabilize the rocket during flight.
So true.
Here comes.
Camera from our last launch. It's 730 views, Daniel said.
Is 730 what?
Views.
Oh.
Okay.
So,
Thrust structure.
thrust structure. It works.
I hope so.
It just works. Immediately above this thrust structure, inside the rocket airframe, is the
Motor.
the motor's in the thrust structure.
Oh, the air brakes.
The air brakes. Seth, you should talk about the air brakes.
I am the expert on the air brakes or something like that. So I made the air brakes mechanical and electrical system, kind of. They basically slow the rocket down. Originally, it was supposed to go to about 5,000 feet, but now it goes to 4,100 feet, according to Joseph's calculations. And yes, so it puts out flaps, which are control surfaces, and increases the coefficient of drag, which basically slows it down. It's like pumping brakes on a car, but instead you're going up in the air.
Air brakes.
Air brake.
Yeah.
Air brake.
Do you want to explain what our lovely CEs are doing over there?
ECEs,
Or ECEs.
electrical and computer engineers.
But
Yes.
they are the
Generally,
computer ones.
what they're doing is they are APRS. I don't know exactly what that stands for, but it's kind of like ham radio. Awesome packets. Automatic packet report system. I'm still holding this motor.
Give me that. Give me that.
Yeah, so APRS is. Oh, there's the microphone. Yes, so what it does is it packages these packets, the data, such as your pressure, your temperature, your velocity, your acceleration, and all that stuff, and then it sends it over radio frequency, and then you can see up there, I don't know if you can see my hand, but up there, it receives them and then decodes said packets, and then it records them in the transmitter, or not transmitter, receiver. Yes. Then that's the main payload. They have a bunch of stuff, and then they have a backup part of it just in case the main part of it fails. Above the air brakes is a shock cord mount that's made out of aluminum, and that is held in so that when the rocket deploys with the parachutes, that it holds together. And then above the shock cord mount is your avionics bay. Avionics literally just means electronics in air. So aerospace.
Yeah.
And then that has the top and the bottom. Bottom and the top has places where it deploys. So it has gunpowder, and then it has backup gunpowder. So it has one level of security and then two levels of security, so that when you deploy it, it basically falls apart. And then the little, you don't remember what those called? Those are called shear pins. Yes, the shear pins break, and then the parachute comes out, and then it goes down. The top one comes off first, and that is the drogue chute, and then the bottom one comes off, and that is the main chute. It might be backward. It might be the bottom and then top, but it's drogue and then main. So drogue slows it down a little bit, and then main slows it down a lot. We changed our main parachute from last time. Last time, I believe it was a parabolic. Now it's a different shape.
And it's bigger.
It just looks bigger, yeah. Well, actually, toroid. Half donut. Okay, that's what it'll look like. Yes. And then above that is the main parachute, as I just said, and then above that is the payload, which I just explained actually, and then the nose cone. The nose cone was built by Mr. Jack Keelan, and it is made out of PET-G, which has a long chemical name, but basically just means fancy 3D printed plastic. It has epoxy on the outside. We were originally going to use different types of fiberglass or carbon fiber around it, but that was really difficult to do. So we're just using PET-G plastic plus the epoxy. Originally, it kept breaking. That was basically the reason that we've had to redo our original launches multiple times, is because of the nose cone breaking, which is kind of silly. But what he had to do was reinforce it from breaking. So it was breaking via bending. I just pressed a button.
It still works.
Oh, okay, still works?
Yep.
Okay. And then, so what he had to do was put rods up through it to make sure that it doesn't break in bending. So when it bends, it goes in compression on the top and then tension on the bottom, and then it breaks apart the 3D printed plastic. But this time, Jack put 3 or 4 pins. You know how many pins he put in the nose cone?
I think 4.
4 pins. So it reduces the amount of stress. But actually, it doesn't reduce the amount of stress. It just increases the amount of maximal stress required for critical crack propagation. Basically means it don't break.
Which is a good thing.
That is a
We've
good
broken too many nose cones.
Yeah, basically.
4 pins.
Yeah, 4 pins.
4 pins.
So I just got to the top of the rocket. What else is there to talk about? You had a presentation today. How did that go?
So a very interesting part, a really interesting part of this project is that it is not just a senior capstone that Cedarville engineering students do. It is a national competition that NASA puts on for universities all around the country. So this competition, this flight that we're doing, is being judged and graded against universities such as Purdue, Notre Dame, Ohio State, and so on. And part of and even though it takes a village to make a rocket, it also takes a village to write all the reports that NASA wants. So a large part of this project is documentation.
Amen.
One of the most important things I've learned in my journey through engineering is that it doesn't matter how smart you are if you cannot communicate.
Amen.
If you cannot communicate and remember what you did, as I often do not, you're toast. That's a great way to say it. So we have written 4 large reports to NASA.
How many pages?
Over 200 pages per report, documenting the preliminary design of the rocket, the critical design. So we chose our path, and then we decided on critical numbers, critical design systems, and methodologies, and then implementation, and then we had, what was the one?
The FRR.
The FRR, which we just submitted.
That's the implementation.
The FRR is the flight readiness review, basically meaning, hey, not only did we design it, we built the dang thing, and here it is, fully tested, fully vetted, ready to fly.
Yeah.
So
basically verifying. You're running verification checks. So the air brakes had, I think, 17 validation checks that it had to run through before we said it was allowed to work. Those took place actually throughout the course of the year, but one of the checks would have been like a pre-motor test. So like, does this motor actually work? Yes. Okay. What about the mechanical system? Does it actuate as designed? Yes, it does. Or the electrical system, does it blow up? Yes, it does. Oh, shoot.
Whoa, hold on. That's against the law.
Yeah, so different things like that, and certain validations were passed, certain validations were not passed, and then it has 7 requirements, not validations, that must be met in order for them to say that it actually does work.
Yeah.
Fortunately, one of those is simply like a center of pressure. Okay, that can be tested and done before it's
Easy
put.
peasy.
But basically, the rest of them are actually tested in flight.
A lot of what that has been the purpose for is it is bad engineering to point at something and say it works. That's bad.
That's true.
That's bad engineering.
That's not engineering.
That's not engineering. My car that drove me here worked. That does not mean that I understand what it did.
Correct.
And that's why we do these verifications and these long reports. So that we can prove that we know how and why it works.
Anything else?
Yes, more. Presentation. Another part of this competition is taking those reports we mentioned earlier and
Presenting
them
them
to NASA. So we have gone in front of NASA and have presented our findings. So today I wore a suit.
You looked very handsome.
Thank you.
That's what I would not normally say on camera. A very politically correct version of me saying that.
Oh my. Anyways, I wore a suit today. Daniel, our chief engineer, is still wearing the top half of his suit today. And
We won't be able to see him.
and Rebecca, our electrical lead, was wearing a dress, no suit. But we sat.
Were you
She
wearing
was-
a dress?
I was wearing a suit. We were sitting in front of a panel of real NASA engineers, logicians, and people,
Technical writers.
technical writers, the people that actually sit behind
NASA desks.
NASA and do it, and they listen to the information that we presented for this flight readiness review.
What did they say?
They gave us a few pointers, honestly. They had a few things to say about some of our raw data that we accumulated, how it could be cleaned up and improved, ways that we could improve several other systems.
It's kind of cool.
It is very cold out here. My hands are cold. The good news is that they honestly said that they loved it.
That's awesome.
And that they wish that we could be there to launch it in person for competition.
And then you said,
And then I said, well, maybe you shouldn't have put the day on our graduation day, NASA.
Yeah.
That is a joke, because NASA is an excellent industry giant.
they're
But
not industry,
also,
they're government.
they're
No.
government. I'm not going to say anything more.
Are we in China?
I am an American. That's right. That's true. Exactly. A career
limiting
maneuver, as Mr. Kinsinger, a beloved professor, would say, a career limiting maneuver, which is
CLM.
talking without thinking.
Yeah, basically.
There are also RLMs.
Limiting maneuvers.
relationship limiting
RLM.
maneuvers. Anyway, that's a different conversation. Love is a Science, an engineering podcast with Grant Parker and Seth Mitchell.
Love is a science. That'd be so funny.
That actually, we should do that. Actually, that'd be
This
really
is
good.
basically a podcast at this
Yeah,
point.
this is turning into one.
Okay, what's next? What
So,
are we not talking about?
so we've talked about the rocket from tail to tip.
Yep.
We did talk about it from tail to tip. Joseph,
We
I'm
talked
sorry.
about the antenna.
We talked about the antenna of Doom. We talked about.
Oh, did we talk about?
We should talk about Dave in the NAR chapter.
Yeah, you could talk about that because I don't really know.
I
that
know a
much.
lot about
That's
that.
Awesome.
Dave, yell at me if I say anything wrong. Yeah, that would be lovely. You take your time getting set up, and whenever you're ready, just let us know. Oh my, would you be willing to? Guys,
Just put the microphone right next to it.
with us today is Dave Combs, the member-elect president of the Right Stuff Rocketeers, a local chapter of the National Association
Did you say
of Rocketry.
self-elected?
Member-elected.
I was running against Gold
That's tough. Oh, wait. Oh. Here, you ready? Let's go ahead and watch his pop test really quick.
Continues to focus on
And we
Grant's
can
face.
talk about what these pop tests means in a second.
Yes. So what is in the rocket? Why does it not fall apart when it launches?
That's a great question, Seth. So there are these things called shear pins, which are basically little delicate screws that go, well, not delicate, but
they're metal.
they're metal, but they're screws that go in the rocket body to keep the sections connected. In flight, we need to separate the rocket so that the parachutes can come out so it can slow down and not hit the ground really
So true.
fast. So how do we separate these sections? Black powder.
Yeah.
Explosions.
The things that exploded industries in the Civil War.
Yes. So, Dave, are you almost ready?
I'm ready.
Okay, let's watch it happen.
Not be in the way.
Get out of the way. All right, stand clear. 4, 5, 4.
Here we go.
Wow, you're taking a long time.
Oh,
3, 2,
Pop test.
1.
ooh.
I think that one was good.
So that was a pop test.
That one wasn't even as loud as the last one.
Violence is good.
So
I think it worked.
there's a phrase in the local rocketry community, or actually the national rocketry community: blow it up or blow it out. The idea behind that is it's better to use more black powder to separate rocket sections than less, because
Little explosion. It is safer to blow the
A
rocket
little
out.
explosion never kills.
think of it this way. Let's say you fire a rocket a mile high
Blow it up.
and it comes down, but it doesn't recover well. There's no parachutes. Well, heck, you have like a really fast projectile, a missile, an 8-foot-tall missile. That's not good. But imagine you put too much black powder in it. It would simply explode, which is also not good, but I would rather be pelted by rain petals of fiberglass than an entire 8-foot rocket going through my body.
Amen.
Amen.
Yes.
So anyway, there are these little things called shear pins that go in the rocket body, and when you ignite the black powder, actually for our rocket, it's about 400 pounds. 400 pounds of force.
Really?
Yes.
That's a lot of pounds of force.
That's a lot of pounds of force. That's what the NASA engineer said today. He was like, I was doing some calculations. 400 pounds. Oh my God. Anyways, that's pretty good. So that amount of force separates our rockets. The reason
amount of force.
is the amount of force. Boom. The reason why we do these pop tests is because it is better to know on the ground if it will separate than figure it out in the air.
In the air. Yeah, I found that with aeronautics and astronautics, it's very important to test everything because everything goes in the air and you can't test anything in the air. It just demonstrates whether it works in the air. So air brakes, for example, have failed every time when they're in the air for one reason or another, and it's quite unfortunate. Well, I've flown my electronics a couple of times. Those were mainly either coding or hardware faults, but at the same time, when it's up in the air, you can't test anything. You got to test it all on the ground, versus kind of like a car. A car can be tested on the ground while you're even in it, or a bridge or something. Anyway, I don't know. That's the whole point. That's what I just said. You can't test it in the air.
I mean, you shouldn't. I mean, it's still the same problem.
I know. I'm being facetious. I'm saying that mechanical engineering is harder than all the other engineerings.
Oh my! What a claim! What a bold claim!
No, not mechanical. I'm saying aeronautics because you're on the. It's like aerospace stuff.
Yeah. Wait. What was what's going on?
I'm just.
Are we starting a fight club?
Yes, I'm being annoying.
Okay.
Okay, I think it's almost time to start doing payload stuff. So I'm gonna hand this off to you and do payload stuff.
Okay. So, actually, speaking of payload stuff, I mentioned earlier that we're doing a mission for NASA. What does that even mean? So every year, the NASA Student Launch Competition happens, and every year they say, "Hey, we have a problem that we want you to solve with a rocket." So this problem solution will take the form of a payload. So actually, could you rotate the camera to look at that? What Kenneth's holding right now?
Yeah.
What's in that nice young man's hands, it's a little sunny, is that electrical beeping device. It's black. That is our primary mission payload. Here, you can turn it out of the sun now. So, this year's mission goes like this. Imagine you're launching a rocket to Mars. It lands there, but heck, how are we going to communicate with it? Well, that's where data transmission and receiving comes in. Our mission for this year is to act as if we're launching a rocket and we need to find a way to transmit data from thousands of feet away accurately from a receiver or from a transmitter to a receiver. So this is kind of cool, crazy, real life stuff. What we're doing is well, actually, I'm not an electrical engineer. I don't know what they're doing.
Fair.
And I'm not even going to pretend to. That's what these lovely folks are for.
Yeah, we love them. They're great and amazing.
I'm just here because I'm tall and I can pick things off the top shelf. Anyways, so yes, they are almost finished setting up the payloads, but these payloads will go inside the rocket, fly thousands of feet, experience 10 G's of acceleration, hit the ground with tens of pound-feet of force. It is really a rigorous, impressive thing that these devices can survive this flight. And then they will transmit information from thousands of feet away to a local reception point that we can then decode and understand crucial portions of our rocket, such as what was its maximum velocity, what was its apogee, what was its landing condition, what's the survivability of our stem knots. By the way, we have 4 Lego astronauts, stem knots, in the payload.
Yeah.
Fun. So, hi, Dr. Ward. Dr. Ward, would you want to come on the live stream? You don't have to if you don't want to. It's a live stream. Oh yeah. Is there? Hi, everybody. This is Dr. Ward, our professor advisor.
Hey Grant,
do
you have an actual outlet in your car?
No, maybe.
The main laptop that we were relying on has 10% battery.
Okay. Well,
Does somebody have one?
Oh goodness. Sorry.
An outlet in their car.
Or like a
would you be okay with Oh. You don't have to. No, okay, that's fine. Yeah. Well, this is Dr. Ward. He's awesome. Everyone at home, give him a round of applause.
Woo!
Woohoo! Yay! Yippee! He's hanging out with us here in the cold, making sure we don't do anything crazy. But yeah.
Like this laptop with no battery.
Come with a laptop with no battery.
Yeah.
Actually, speaking of that, I'm going to go check my car to see if it has an outlet. So I'm going to leave this. Thank you, Dr. Ward, for coming in and being celebrated for all the work.
Yeah. All right, so they're still doing stuff over there. Kenny's got our payload.
That was energetic.
Yeah, it works.
Yeah, 11 and a half feet tall. Yeah.
How thick is it?
It is a 7.5-inch diameter. It's a 7.5-inch diameter cardboard airframe. This is a production kit from Lock Precision. It's called the Force 10. This is for my EEE Level 3 certification. What that means in a nutshell is that if you want to fly really, really big rockets with really, really big motors, you kind of have to prove that you know what you're doing and that you can do it safely. So, for a level 1, no big deal. You just build a rocket that can tolerate an H motor and you're done. For level 2, you have to take a written exam that has questions about safety, regulations, uh, assured clear distances, and that kind of thing. And you have to fly either a J or a K or an L motor. Level 1 is H's and I's. This, for a level 3, lets you fly M motors and above. Those are the largest ones that are commercially made. And instead of just taking a test or something like that, you have to build it as a project under the watchful eye of an experienced mentor. Mine is a person out of Germantown, Ohio, Gary Dickinson. He's actually the secretary of the EEE national organization. It's kind of a big deal, but he's a great guy. He's really nice, really smart, and he is getting reports from me probably, once every week or so on the progress that I've had. So the rocket as it stands now is construction complete. I have no more parts. I don't have to mix up any more epoxy. And what you just saw was what we call a pop test. The team, the Cedarville team, just did a pop test on their rocket because they had the new parachute and they wanted to make sure that it would deploy it at altitude correctly. I have to do the same thing for this. I have to figure out how much black powder to use, and there were estimates that I got from a program called RockSim, where you enter in all the different parts, their dimensions, volumes, and that kind of thing. And it kind of figures out what your black powder charges ought to be. So I took its advice and I tried it, and both the drogue separation and the forward separation, the main sep, were pretty vigorous. And it's also part of the requirements for level 3 that you fly redundant recovery. So I actually have 2 altimeters in the altimeter bay that control 2 different sets of charges. It's all about safety and making sure that it works when it's supposed to work. So that's the rocket.
Yep. Thank you for all of that
Oh,
wonderful information. It's a very big rocket.
It's 11 and a half feet tall.
That's very
It's
tall.
going to weigh 40 pounds with the motor.
Wow.
So, yeah, 40 pounds at the pad. And we're going to be launching it, not today, but we will launch it off that same launch rail that we've got out there in the field that the team's about to use here pretty soon.
Yep. Let's go check on them. We got some people over here just chilling, probably literally chilling. Ooh, Jack just said we have a drone.
Eventually, not yet.
Oh, that's eventually.
Daniel. That's why I said I have no idea.
They're putting in the payload or air brakes.
If you need gloves, I have some.
You can't really see, but there's spaces
Sorry, my
for
necktie
flaps.
is in the way.
No, it's actually not.
There you
Yeah,
go.
you see
By the
those
way.
spaces? That's for the flaps for the air brakes to go out.
Hanging on. The airframe.
Are they going back to campus? Another like 40 minutes. Probably back.
We don't have enough.
Oh,
I know.
oh no.
Okay. So you push from the top.
Push from the top.
Yeah.
That's That's why I said if you want close. I'm pushing pretty gently, pretty hard now.
Okay. All right. Oh, I remember what worked.
It needs to go in, but not break it in the process.
Get domed.
What is the problem? Is it the epoxy?
This. Okay.
Same place as stop. Oh, that's further. Hold on. Yeah, okay. Oh. No, it's fine. I just gotta pull this around. There we go.
There you go.
There's a possibility that we can do a fit test and an actuation test. Sorry, Arkin.
They're in the car.
Do we have to put this in first before we do the other stuff, or will this? I know. I'm just saying. Last time we put this in first before we got that in. I was just trying to get this in first to see if we had clearance to plug in a Raspberry Pi.
It should be okay. If you can.
We don't have. I know we should go down more. We don't have room for clearance for that. So if we need to pull it up just a little bit to put that up first, because it might be a pain in the butt. It does. It's either we
right.
we can either push it in and put that on, or we can put that on, pull it out.
I'm fine with doing whatever.
It won't work for him. We won't be able to do an actuation test. Oh, right. Because we have to be able to plug a Raspberry Pi into there. We can't do it in there. Right there. It's like all the way down here now. And unless we like mega stretch that and keep that cable with like that's all the way stretched. Like that's all the way stretched. So we might be able to. It might work. That is all the way down, and poles are basically lined up now. So if we can.
Yeah, absolutely. Okay, good. Right.
All right. Put the flaps on. With all. Don't have any of that.
Yes.
Where are the screws? Got it. My back hurts so bad. It's getting better.
Not after today.
But it like because it's so cold, it's just like
Oh yeah.
tense.
Cold sucks.
Yeah. That's why it's like whenever anybody says they like the cold, it's like telling me they liked when I suffer. like
They're basically
I just love it when you suffer so
As
much.
soon as I say they like the cold, just like you don't have any joint problems. That's what that tells me. You spry.
What happened to the
Oh, no.
It's
yeah, that's what it feels like.
There's some mule nose wires.
We have our payload back. It's here.
They should live now.
I think there's like epoxy that got painted over it.
Oh
That hole
jeez.
should not be obscured.
Yeah, it wasn't before.
It definitely wasn't.
Do we ever drill?
Drill, we're fine.
No, we're good. It just we're good.
It does look pretty cool.
What is it supposed to be?
It's like put that in the requirement table. Looks dope.
It's very shiny.
It is very shiny. Is there a reason?
Because we needed a translucent cover that is bendable, so we can see through it a little bit, but like protects the payload. It's requirement by NASA for it to be covered. And that's what Dr. Cole had, and it was really shiny, and that looks like a space thing. The space thing is so shiny.
That is true.
This is how cold it is right now.
So number one, it's a requirement. Number two, that was what we had on hand. And number three, it looks awesome.
Yes. The awesome part is just a plus.
Well, no, that is my official
Okay.
list of
Okay.
reasons
I'm
why
gonna
we
make you
need
fun.
it.
That's literally what it feels
One,
like.
it's required. Two, that's the type of stuff we had in hand. And three, it's awesome.
Yes. And apparently Alicia has an explosive.
Boom.
She's walking away with the explosive.
I don't have it anymore. You can't claim anything.
So that means somebody else has the explosive now.
It's the
cold
table.
now.
Ah.
Me when I hand you.
Two dysfunctional old men.
That's what it feels like. Oh my goodness.
Bad joint.
Literally. Oh my gosh. No. Okay.
Where is that?
Call me Sonic, because your knuckles are freezing. Sonic
I
and
got it.
Knuckles.
It just
It's terrible.
I appreciate the tempted game.
Thank you.
See that in Minecraft? I did actually.
Absolutely not.
The
Here
theaters
goes
were
another one.
crazy. I heard it was really stupid. Yeah. Please. It's very stupid, but it's very mean. That's why it's really
Yep.
163 billion.
No, it's built.
No.
It's million. Not billion.
No, I know it got up to like 300 million, I think, now.
It is
I was like, chill, bro.
Go buy an aircraft carrier with the amount of money the Minecraft.
It's the U.S.'s budget for
the U.S.'s GDP
for like 10
was
days.
doubled
because of the Minecraft movie.
It's pretty close.
Kind of
The problem.
So while they're screwing that,
unless you're hitting the airplane.
they are preparing over there. Putting in the payload.
I saw those. Those are right below the hole.
The hole should be like right there. Can you push?
Hitting the coupler too?
Cable management.
Yes.
That's super mileage. They just tell you to zip tie things though.
Cable management.
I looked over and it was a microphone.
Yes. We now have microphones. There should no longer be any sound issues.
You said that it's gonna
If you want to do that,
because that's how things work.
No, don't do it. Not you.
Well, currently I can hear everything that's being said, so it does work.
look at those big arms. I have some pretty big forearms.
I don't know.
Come on, man.
Oh, white glove service.
All the way right here. Thank you.
Daniel, you have to be so cold.
I think he was trying to like ignore it. Just like if you don't talk about it, you're not
Okay,
actually.
I can't use a hammer right now. I gotta.
That looks cold.
Whoa!
You never think about it the same way again.
It's not working, Daniel.
I was able to push it off.
It moved a tiny bit.
I watched enough.
Daniel, this is the same payload tube, right?
As what?
You haven't done anything except paint it.
Oh, it's the same. It's just completely different. Yeah, it's the same.
There's
no more epoxy or anything like that, right?
No, ma'am. It worked.
It puts a lot of
The
like.
baby is born.
I was gonna say head down or
It puts a lot of stress on them, though. I don't love it.
Probably if we had loosened the top ones, just made it a little better. I don't know. It's because it's all on that, loose carbon fiber rod.
Well, I guess more strengthening is better, right? More folding in,
Yeah.
because these are exact, correct?
Yeah.
Okay, so these are more precise
Yeah.
than what I have them in. Have you tightened these yet? Okay, so I need to actually tighten them.
I think they're okay. You don't want to break the heat setting.
Right. Yeah, that's why I was asking.
I'm having this problem where I can't button my shirt up.
Your hands are cold.
Could you mind?
What is that?
What is happening over there?
Okay.
It's a shear bed.
I knew we were catching it.
Sheer
Can you prepare to actuate these?
still in there. That's hilarious. Okay, for that, yeah, use the small screw and like push it out.
Thank you.
I mean, technically.
I was like, there's nothing that's changed.
Yeah, there you go.
Yeah.
Oh yeah,
It
Daniel.
fit.
Oh,
I got it.
perfect.
I need the paint.
Which one was that?
Wait, what?
Your what?
The fancy screwdriver. They need it. Where it is.
I was gonna say, where is it? Oh, over there.
Coming.
Oh, are you? You're not charged. Dave has a charger. Charge your laptop.
I have 8%.
No,
Okay.
charger on that top.
Charge it.
You charge it for right now. I don't. I'm not perfectly ready.
It is
And
it.
those one we will be doing very carefully.
They did it.
Oh, Daniel, look at that.
Look at that.
Can't hit that switch.
That's much
Oh,
better than
man.
last time.
It's beautiful.
Watch it collide.
We won't have the screws to put in the
It's legitimately possible.
Yeah, we really haven't tested it super well.
No, we have not tested it at all.
Well,
It should work. The CAD shows that there's
the CAD says it'll
The
work.
CAD shows that it will collide because it doesn't have like the chamfer in there in the CAD model.
Well,
But
we have a Dremel.
I cut it down a lot. Like it should be fine.
I did the kinematics a semester ago.
That is
Guys,
no,
we're
that's
trying
nothing
to
to do with-
listen to something.
Everybody-
I'm sorry.
That's very buff.
Oh.
I was like, at what point
Did
do we
it
get
work?
this?
Exactly.
Well,
I'll hold it.
does one of the flaps has a crooked top?
I think that might be just.
Yeah.
We We found it! Yay!
No, it's. I mean, it's. You can see it as long as there's two in there.
Yeah.
They're so pretty.
It is.
Right, we're getting there. Indubitably. Jesse,
Front structure can go in now.
you're gonna be honest, Jesse.
The front structure.
We are very much
All right, I'll do it.
appreciating daylight savings
Well,
time
I was.
because now the
Said
sun
everybody,
is still
Front
up.
structure can
Okay,
go
that'd
in
be a good
now.
decision.
Okay, Daniel, why don't
Check
you do
stuff
that?
off.
Meet expectations.
It exceeds
Set up
expectations. There's a little
This is
bit
mine,
of tape
don't-
on there. Why didn't that come off?
Thanks, guys.
He's charging Arkin's laptop. In order to charge Arkin's laptop, you need a full V8. Okay, the top screw is not loving me right now.
That was the hardest nut.
Yep.
Sign this right here. I can't remember.
Jack
how well
is
it-
going through the checklist.
About halfway there.
Hooray.
I want to sign in.
What are you signing?
Arkin, you weren't even here for when they were testing it.
Hold on, what are you signing?
We're gonna have all three of you be payload.
Nothing breaks. All LED again. Radio frequency is still available.
Well, did we check that?
We checked it previously.
Okay, it's probably good then.
Alright, I'm testing.
You have a word for the people.
Well, busy.
Do you?
It's a single word.
I'll see what I can do. Use this problem. Like,
It's incredible.
He has to
Oh, yeah,
think
Jesse
of all the
narrated that.
words
Oh, yeah.
and narrow it down.
kind of fiddly. It goes in really nice when
Mallet
it's all
works
lined
too.
up, but-
Mallet works really well.
That was my word.
Okay, hey Jack.
Did he give a word or did he just stare in silence?
You can just do it
In silence, yeah.
It might be in the box of the car.
My word is 42.
Oh, yes, because that's the answer to life, everything.
I was hoping you'd understand. Yep.
I know that because of her. Hitchhiker's,
too well.
yes. Hitchhiker's Guide to the Galaxy. I know it, but I haven't read it.
I've seen it. I have not. Like I saw the movie. I've not read it. But I was also familiar with this joke before.
That was actually where
But I need to read it. I need to read books in general. I need to graduate first, though.
Yeah, and she's
That is
going
One
back.
month.
No, but then you're going back to school.
I'm going to grad school, but I will spend the entire summer just like working in the lab at grad school, not actually doing classes.
That is true.
Oh yeah, so this is very exciting changes coming.
Yes.
Graduate May 3rd, get married the 31st, and go start grad school.
Yeah.
Where I shall research in the lab all summer, and then do classes and research in the lab some more, and then write papers on that. and hopefully
Sounds so fun. Totally.
If I'm in the
Our
shot,
kid's
I'm
word
doing
was nerd.
Nerd. Yeah, that's pretty accurate. And you're marrying a nerd too,
I
so.
am. My fiance was on this team 2 years ago when he graduated, so
And he is going for his doctorate.
yes, he's gonna get a PhD in electrical engineering in
Oh,
robotics
wow.
and neural networks.
That was an interesting
Fancy.
positioning of that. Of this
Yeah, his robotic blimp competition is like starts the day after Easter. So
Wow.
No, but a washer.
The flaps might be on now.
Right here. Yep. Do we have one? Yeah.
my feet were cold before we got here, but not like very. Now they're really cold.
I could.
Yeah, we're
this is what
cold.
I could do.
I just have one.
I have socks and
I have
really
one
warm
and
socks.
really beat up boots.
Their socks, really warm socks, 2 layers of leggings, and hiking boots.
Probably.
I have jeans and leggings and warm socks.
Not at all.
And boots, yes. I
I
do
don't know how
have
you
shoes
don't have a
on.
hood up.
But
I don't know how you can stand a view without a hood up.
She's on you.
my head is not cold, it's my fingers that are cold.
My fingers are okay, but only because I've in my pocket gloves on.
Yep.
I've been keeping them in my pocket, but that's because I'm gonna need my fingers soon, and so I don't like not be able to move my fingers.
That's the problem I'm running into with my toes. Arkin.
Arkin has taken control of the camera. I don't know if that's
Does
wise.
this camera do anything, or is it all this?
No, the camera is videoing. That camera, the phone camera is doing nothing. The phone
Very
is,
professional.
It's just the best way to be there.
it is. We have a good camera with good sound from the new mics, and then we connect it to YouTube through the phone.
You want to zoom in on the moon, Arkin?
Yeah. Let's see, Elon Musk.
Low,
One of the cars.
low. Ooh, it's doing
Someone
really good.
message Grant and ask
That's
where it
as
is.
close as we can get. That is the moon.
Wow. Now let's see this resolution on Kenny's face.
Brian and Dr. Ward went to
Kenny's face is much lower. Oh my. There's Kenny.
He decided to do a trip.
Perfect.
Buy the drone.
Oh, you come in. We need the screws we have to assemble the rocket.
For the nose cone.
Where are
Nose
they?
cone screws.
Like,
Nose cone screws
In your pocket.
in your pocket.
I have no idea which track you did to zoom in.
That.
Was it just for Grant?
This is, sounds like Joseph. Why is Joseph in here? Talking to Grant.
What?
They got pulled over.
What?
They got pulled over.
Remember this
That's
conversation
an
we
FMV.
had?
Okay.
That's a
How did this happen?
You guys
That's
okay?
all this. We had a conversation on the way here about speed limits. How it totally applies to you.
Yeah, that's true. We're definitely not
I'm
lying.
pretty sure that is
On the car ride over, he said it's only
Those were his exact
Who said that? Or do I not want to know?
wild guess.
Okay.
Joseph answered and said, yes, we got pulled over.
Is he driving?
For Grant's phone.
Oh.
Why did Joseph leave anyway?
Yeah, why
Doesn't
did
have
he
to do,
leave?
like, avionics?
Joseph, Grant, and Dr. Ward went to go get stuff.
Why?
Why do we keep sending Grant places instead of like me? I don't know.
You want to get pulled over?
No, but I also don't have any important screws in my pocket.
Failure to follow the rules
Yeah,
and laws of the road.
Maybe a little bit more.
That could be cool.
Failure to
Like,
comply.
they almost here because we don't even gone yet. No one knows.
Were they on the way here or on the way back?
We don't know.
P7, P8, RS1,
They stopped answering, so I
RS5.
kind
Yeah,
of
that's
hung up.
definitely all
Figured
there.
I'd let them deal with that.
They do though.
Who knows?
Oh,
Probably.
Grant was definitely.
Can we get a police escort to the launch site after which you can give me a ticket, but I need to get
We're
this to my
launching a
teammate.
rocket. Right.
Can we go pick them up?
No, really.
Yeah, can we go
yeah,
pick
send
them
someone
up?
out to
No.
pick up the-
You can't just show up at a police encounter. Like, can you imagine if police pulls you over and then, like, there, you know, talking to the people, and all of a sudden this other car pulls up menacingly, and it's like, we've come for the people.
We come from
Well, not the people, just the
Just
police
the
and-
screws.
Oh, we just need the thing he has, then we'll leave there.
Yeah.
Yeah, can we just go through his
It's
pocket?
not a.
No, definitely not.
No, just because we are working with explosives doesn't.
Parental supervision.
Yeah, we put the.
You gotta start printing stuff off for Grant. Nope, we'll do. Well, technically, Joseph, you.
Oh, is this a safety violation?
No, for sure.
Hey,
For
What?
sure.
Them,
safety violation.
for them getting pulled over.
Failure to follow the rules.
Yes.
I
Oh no.
don't know. I can't.
It's in the checklist to follow the rules of the road.
Yeah.
I did not know that had to be put on the checklist.
Not getting pulled over?
Yes.
Of course, this is the first thing we put on.
Road crimes is a very interesting way to say that. All right, Arkin, I'm ready.
You committed arson.
Well, I'm ready. You can just start testing.
Ooh, we're testing the air brakes.
I might need to go sit in the car. I can't feel my.
I wish I could, but I cannot.
You're just gonna.
No.
It works twisting with these.
No.
Oh, okay. Ken, you must be made out of steel. You were wearing like 2 layers, hardly.
Yeah. The moment you guys need either me or Alicia, come find us in my car. We're sitting there to warm up.
Yeah.
Thanks, Dave. Hold on. Boot cell. Do not boot cell.
Careful when you turn it.
Yep. Just let us know, because we have to turn these electronics. Press the switch. I can just turn it on here.
Arkin! It's not supposed to do that.
Ready? Okay, we have to make sure that this is off of.
Okay, lift it up.
It's ready to be actuated. Okay, air brakes activation test. Did the washer work?
Yeah. Ready?
Dude, like just 10 degrees.
Okay, you gotta lift it.
No, it's ready to go. It's not
Lift it.
touching it.
Careful.
Everything.
Freeze. Not in that one.
Yes.
Yes, it worked.
Dr. Miller,
It worked.
we're testing the air brakes.
That's so cool.
All right. Beautiful. 35. Okay, I'm going all the way.
No!
Yes. Back down.
Yes!
Ooh.
Uh-oh.
I think it's a 1. It's not. Oh, it's not.
Tell it it's not.
Exactly.
Zero it.
Restart it.
Did you take the button functionality out?
Yes.
That's not 0.
But it can't go down anymore.
What do you mean it can't go down?
It's a negative 1.
It totally is not a negative.
No, this means the button's hit.
Brother.
The button's being pressed. Well, you can turn it off and close them. And then, yeah, if you want to do that,
We
and then turn
we
the
cannot
buttons,
do that.
The button's being
Why
pressed.
can we not do that? Adjust the screw on the desktop then?
Did you not adjust it?
No, we did.
Well, it's
You
at
make
0.
it higher?
Wait, we can't.
Because when you're playing with it without anything going on, you don't know when the button's pressing.
Can you see where the button is clicking or if something's moved?
Where's the
or...
button? Is the
button
on
is
this
down
side?
there, yeah.
I can't see.
It's down there. Okay.
Dr. Ward
Nope.
is in
Yeah.
Harvard.
Oh, sorry.
I need to find the button first and see. Get a good glimpse on some side. I'm trying.
It's applied for all this stuff.
You can't see from the top at all. Oh! Nope, the
Nope,
shark
don't do
checker
that.
is there. I'm trying to find it. Where is it? Oh, I'm looking on the wrong side. I'm an idiot. Okay, I find it. Ready?
That's better.
It is.
No, it's about the same.
Oh.
See?
Oh, well, 2 of them look better.
Yeah, when you see it. So I think because of all of that wiggly and jiggly, when I pushed it, when I pushed it down and it moved the button up just like 1/16 of an inch, which is giving us this amount of.
Would you be able to adjust it while it's still in there?
No, we have to take it all.
When is sunset?
It's 8.
Is this?
Probably about 10 after 8.
You got an hour.
We get to enjoy the sunset.
I think that once we move the mechanical system around
to where it was supposed to be.
exactly, and this has shifted a little bit, and the button has been pushed up just slightly, and a small amount of movement especially at the lower portions, make this at a larger angle. Like a 1/16 of an inch is like by 2-3.
Okay. What is the
Because I know that can go lower. It doesn't know.
how at what altitude here is the
What was ask that question in a different way?
the top coupler between the encoder? Where is that here? Can we force something to turn it a bit lower? Like while it's closed, essentially.
We could, unfortunately, not use the button and just manually set it and say this is 0.
Is it a physical or an electronic limiter?
Both.
Okay.
So does it have to? Okay. Does it utilize the button when it stows the air brakes?
That's a question for Arkin.
Yes. Yes. Is it?
But here's the thing: once it stows the air brakes, it's not a huge deal if they're not completely and fully deployed in, like stowed in.
Got about an hour.
We just don't want it to freak out if it tries to close and there's no stop breach. You have to revamp the code so that.
What do you want it to do? Oh no, I don't think we should. I don't think there's any case in which we want to say no button.
Correct.
Well, we can set it manually for this launch. That's fine. I just didn't want it to freak out when it tries to stow it and then it kill itself. Trying to close. Yeah.
The other question
Does that make sense?
is this okay to launch with? Like, can we have it out like what, 3-4 degrees?
No.
That's not good enough.
We can close it manually. We could twist it. We might have to take it all out. We can do that. Close it. Fly it in the closed configuration.
Like it starts closed.
Yeah.
Yeah.
Yeah, we can
What are
do
you
that
doing right
manually. Instead of just remove the button.
Wait, why remove? Well, on startup can we just close? Stay closed because you had it closed all the way before you just ran that.
Mm-hmm.
So the question isn't whether it can go all the way down. It can go all the way down.
Yeah.
It's just we can't do it. So if we can do it manually, if we can pick something on the side, turn it that last eighth of a turn, then it's closed, and then we can launch, and we'll open the others.
Exactly.
You're talking about the screw on the.
Yeah, just
I'm
rotate the lead screw right now, and then it thinks it's at a 0 position. It doesn't have to 0 itself,
Right.
and it runs as it would normally would.
Now I can make it override what.
The only other problem then is that there are points in Joseph's control algorithm where it does go down to basically 0.
Yep.
And it's not going to be able to do that in flight. Saw that. Well, unless we remove the button.
No.
In
It
flight,
won't be able to actually go to 0. But it'll go to this. It'll go down to this.
We can. I can also just say when it hits the 0 button, it's actually like 5.
I was just about to ask if you could just set 0 as negative. Just give it a offset error.
Okay. That is
Yes.
risky, but since the end stop is so squishy as it is, that might be a way to go.
In theory, it should be fine. It's just untested.
This should only trigger on a rising.
Good footage of whatever happens. No, we don't, but we're facing like we could overamp everything. There with it. Still, no. I think we could have a qualifying VDF. The thing is, things are hard to diagnose. There are a bunch of compromises. There it is.
Man of the hour.
I'm so sorry.
So another problem. So what are we thinking? We could. Oh, I have an idea.
You have to
gotta
say
tell
the
us.
idea, so,
Or
otherwise you're not allowed to do it.
I'll just take one of these flaps off, and I might be able to access the
I can also just
piece
tell
by
it that
pushing
it's
it up.
Oh.
I don't think I have to take the whole thing.
Even though the screw head's on the underside.
Yes.
Or did you change it?
No, I put it on the underside, but I forgot that it's not always at the bottom. As you move the air brakes up, I can just probably barely move it
Okay.
up.
Let's try that first.
Can you, somebody do
That's so exciting to see it.
That's so soon. It's gonna. I don't want to say that. We're on live.
Oh,
Welcome back.
they're back. They're back.
No, the cop.
Oh,
What?
the copper.
How fast are you guys going?
No, so he said that he blew through stop signs and red lights.
Actually,
said. He
How
did
many
some
stop signs and red lights?
rolling stops. He did some rolling stops. And
Oh.
yeah, we're fixing it right
I
now.
caught the scene all week.
So and then also
And
his
you
insurance
send it
and
to
registration
full
is expired.
You're on.
What?
You're on live stream. So.
Because I can't.
Well, it's everything's okay.
It's
Yeah,
really-
they're here. That's all that matters.
What are you doing?
I need to try and get that as high as possible.
Alright, Sam, let's get this.
Oh, yeah, that was a very interesting.
By the way, so just put a soap.
It's the screw that
Doesn't matter.
We're here to watch rocket.
Yeah.
Hey, Joseph, your phone's about to die.
You need a box to charge it?
Yes.
You need a cord?
Yeah.
Okay.
To plug it into this thing.
Like hot on my tail. And
Could
then
you
I
go
got
to
to the red light.
60 degrees?
Now, coming. By right lane.
Literally, we're not.
I bolts over immediately. So, I mean, didn't get.
Well, there it is, right there.
He did threaten it. And then he did.
It's right
Then
here.
asked
and I said, "Thank you, officer." He said, "Have a good night." Yes. Freaking.
That's just
He said
this
you
side
wanted
of
to
un-
Said I was a bad person. And that's okay.
Did you actually get
I
a
actually
ticket?
forgot he said that.
No.
Yeah.
Oh,
Wait, what?
So-
I was So,
But we have your drone. Thank you. And we have the terminals.
Does it take USB-C? So here's the screw I need to access.
Yeah, it's
I'm
just
touching it with
covered with tape
Where?
right there.
Okay.
I did give you the quote. Sorry.
I don't have USB. I have USB. Can I plug in a USB-C to USB-A cord backwards?
We'll see.
At some point. Oh, does anyone have a wrench? If I can get a wrench right there, I can twist that.
You've been off duty for
an hour.
Somebody have needle nose pliers?
Yeah.
So, don't know why if he's off duty, he's still actually moving around, but you know. Let's call it soon.
I thought you like desperately needed a rocket. I was like, oh my god, my truck's not here. Okay, so what's left to do? The
Well,
truck.
the air brakes just actuated. They don't go all the way down to zero.
So we're trying to fix
We're going to adjust.
Okay, back to zero, please.
Cool. Still going. Cool.
All right,
Ready?
Halo's
We were
good.
worried that we might be from actual flying. Okay, back to zero. Zero.
Yeah.
Yeah, we don't want to get this guy that here longer than he needs to be either.
Okay. Let me know when and if, because that whatever you're doing is more.
Provided I follow the law.
Oh, it apparently just was.
starting it over.
Yeah.
Has this connection been a problem?
No, I
Okay.
just was.
Before it's been taped or after it's been taped? Has it been was it a problem before taping?
No,
Okay.
I just didn't know if it would be. All right, people, if we lose you, I apologize, and we will be back soon.
I gotta undo all the tape. We can redo it after it's plugged in.
I know. I just am concerned your phone's gonna die before.
Started it.
Oh, because I got pulled over? Yeah, that's actually
Okay,
yeah.
test it now.
There you go. I see that, but it is one of the
Your
things
phone's down to 2.
Okay. Give me a cord.
Say about the warning.
Not that one, the other one.
Oh yeah, and he did say that. Now you need to tell me who's riding in this vehicle with you.
Is that 0 with the button?
With my professor, Dr. Moore, my fellow student Joseph. And he's like,
Does it have to be the USB 3.0 or can it be USB 2.0?
I don't think it. Just